So the other day, I learned a cool tip from a fellow teammate, Josh Syak, in which he pre-compiles a keyword value that he uses for fuzzy searching within a collection within an Angular application. So to explore this idea, imagine that I have a collection of friends, and the friends has a name field, an isBFF field, and then a hobbies field, which is just a collection of strings for things like swimming, hiking, golfing, working out, so on and so forth. Now imagine that I want to be able to search on any of these values using a very loose keyword. So let's take a look at the browser now, and you can see here's my collection of friends, and you can see some of them are BFFs, and those BFFs always bubble to the top, which we'll look at in a second. And what I want to be able to do is now start searching. So I want to search for name, let's say Brooke, and you can see we've matched Brooke. Now let's say maybe we want to search just for BFFs. So you can see we're using the term BFF to search for the property isBFF. And now let's look for people who like golf, or for working out, or for dressage, for ping pong, or for anything else. And you can see we also have obviously failed matches. So how is this happening? How are we mapping BFF to the isBFF field, and how are we matching knitting to the sub-item of a hobbies collection? Well, that's where this pre-compiled keyword search target comes into play. So if we jump over into our app component, you'll see I'm importing friends for the demo here, and what we're going to do is actually wrap the friends collection inside of another collection that represents our search results. And the search results interface here takes the friend and then has a sort and a keywords property. And you can see these are both strings, and we're actually going to pre-compile these values when we initialize the component. So if we look at the constructor here, you can see we assign our friends to the private property, and then we call set all search results and set filtered search results. The all search results is going to be the master wrapper around the friends collection, and then the filtered search results is going to be the filtered version of that collection. So we actually have two different collections, and the filtered one is the one we actually render on the page. So let's look at the all search results. So here we're taking our friends and we're going to map it onto our all search results collection. And inside this map operator is where we're going to pre-compile some of our values. So we're going to pre-compile two things, the sort and the keywords. Now, as we saw in the browser, and we'll jump back there for a second, the BFFs always bubble to the top in the sort. And the way that works is that we look at the isBFF property of each friend, and we generate a sort prefix such that if it's isBFF, the sort is going to start with a pipe, and if it is not BFF, it's going to sort with Z pipe. So this way, when we sort on the eventual sort payload, we'll have the BFF sorting essentially baked into the prefix of that string. We then take that string and then add the friend's name, because we secondarily sort based on name, and we lowercase that so that we're always dealing with case insensitive searching. So essentially what we end up with is a sort here that is prefixed by the BFF property, then suffixed by the name, which is why the BFFs always sort to the top. Now the keyword, which is really the whole point of this post, is going to be a single string which aggregates a number of the embedded properties. So you can see we're going to create an array starting with the friend name, and then we're going to concatenate all of the hobbies. Then if it's a BFF, we're going to concatenate the string BFF. We're then going to collapse these aggregate array down into a single string with a new line character, and then we're going to lowercase that again so that all the searching is case insensitive. So now we have the pre-compiled sort, which includes or incorporates the BFF property and the name, and we have the pre-compiled keywords, which incorporates the name, the hobbies, and whether or not it is a BFF. Now, after we call the all search results, we then call the set filtered search results, which is, you can see, the same thing that we do when we're updating the filtering. And we jump down here, and what we can see is that, well, if there's no filter, we just use the all search results collection. But if there is a filter, we then filter the all search results collection based on that single pre-compiled keyword. So essentially, if the keyword contains the filter value, then we're going to include it in the filtered search results. And what you can see now is that by pre-compiling the sort and the keywords, our subsequent sort and filter operations become extremely simple. If we jump down here and we look at the in-place sort that we apply to the all search results, you can see that it's just A sort locale compare B sort. Super, super simple. Similarly, the filtering is keywords includes filter, right? No having to jump through a bunch of embedded properties, no having to loop over nested arrays. We simply look at that single pre-compiled string value and compare it to the string value being provided by the user. Of course, this does very fuzzy searching, but like if we do ON, right, we don't know if that's matching on the ON here in lions or the ON here in ping pong, right? So it's very fuzzy, but that can be completely acceptable and actually quite a nice experience depending on your particular type of application, particular type of user interface. You certainly might need additional filtering options that allow it to be more specific, but for just a really fuzzy in-page keyword-based filtering, I find this to be just a really clever and really elegant solution. So shout out to Josh for showing me that. Thank you.